Hello everyone, today I want to look at this tricky implicit differentiation question. So we've got that diagram there and it says figure 4 shows a sketch of a curve with the equation x squared minus 2xy plus 3y squared equals 50. 4 marks show that dy by dx is equal to that expression. So we're going to start off by differentiating this expression implicitly. And one of the things to be careful of with an implicit differentiation question, it doesn't always say that that's what you should do. But the clue here is that we've got an equation that is in terms of both x and y. So that's the clue that implicit differentiation is going to be the appropriate approach. Now let's look at the various elements. I think the thing we need to be aware of here is when we differentiate this minus 2xy, that is going to need to use the product rule. So I'm just going to say, let's call the u 2x, and let's call the v y. So we're going to say that u dashed is going to be 2, and v dashed is going to be technically 1 times by dy by dx. So if I write down my formula, u dash v add u v dashed, my u dashed is going to be 2, my v is y, plus u, which is 2x, and my v dashed is dy by dx. So that's what I get when I do my product rule to differentiate the xy. Okay, so let's differentiate all the terms. So the x is going to go to 2x, that's normal differentiation. And then I'm going to have minus this expression we've just got here, minus 2y add 2x dy by dx. And then plus, we're going to do the 3y squared now. That's going to go to 3 times by 2y, and that's going to go to dy by dx. And then this whole thing is going to equal 0. So we've done our implicit differentiation. Let's just remove the brackets. So 2x minus 2y minus 2x dy by dx plus 6y dy by dx is equal to 0. So now that I've done my differentiation, I'm just going to gather together the y bits and all the other, everything else is gather together all the dy by dx bits, should I say rather, and then everything else is going to go over the other side. So this is going to be dy by dx, and that's going to be 6y minus 2x. So I've just taken those two bits together and taken out the dy by dx. I'm going to move these items across to the other side. So that's going to be 2y minus 2x. Now finally, I'm just going to divide by the 6 minus 2x. So dy by dx is equal to 2y minus 2x divided by 6y minus 2x. And when we divide every single term in there by 2, I can write that as y minus x over 3y minus x is my expression for dy by dx. And we can see that that is the result that we were trying to derive in the first place. So that's our part A done. Now, one of the reasons I wanted to look at this question is because the part B, I think, is really quite intriguing. So the part B, it says, the point P and Q represent the points that are furthest west and furthest east of the origin O, as shown in figure 4. Using part A, find the exact coordinates of P. So again, this is, quite a sort of tricky kind of idea. And I have seen this idea come up a number of times in exam questions. So it's useful for us to know how to think about this. So the way in which we need to think about this is as follows. Okay, we can notice that at P and Q, we have tangent to the curve there, okay? And in other words, we have an infinite gradient. And the only way that we're going to get an infinite gradient is if essentially we're dividing by 0. So in order to find P and Q, the implication of that is that the denominator here in our gradient function, the 3y minus x, it must equal 0. Okay, because if we want to get a line that is basically has infinite gradient, then we need to be dividing by 0, which means that in this case, we need to be saying that the denominator is equal to 0. So I'm just going to put the denominator equal to 0 and rearrange that to make y the subject. So that y gives me that y is equal to x over 3. So y is equal to x over 3, okay? Or y is equal to 1/3 x. So that's where this is going to occur at the points P and Q. So what we do now is we now take this value of y from the gradient of where this happens, and we sub that back into our original equation of the curve to find out the coordinates of where this happens. So we're going to take this expression for y, and we're going to sub it into our original equation. So that's going to give us x squared minus 2x times by x over 3 plus 3 times by x over 3 all squared is equal to 0. So therefore x squared minus 2x squared over 3 plus 3x squared over 9 is equal to 0. And then let's just combine all of those various elements together. So we've got 1 minus 2/3, 1 minus 2/3 and plus 1/3 plus 1/3 is equal to 2/3. Okay, so we have that is equal to 2/3. So x is equal, so we've got 1. Let's just check that that seems correct. We have got, yes, that seems correct. 1 minus 2/3 plus 1/3, which is the same as 1 take away a third. So that gives us 2/3 here. 2/3 x squared is equal to 0. That's a squared there. So that means that x is equal to, that must mean that x is equal to 0. Okay. So x is equal to 0. Now let's think about that. Oh, I know what's going on here. This is not equal to 0. This is equal to 50. There, when we sub that in, that is equal to 50. Okay, so this whole thing is equal to 50. So we've got 2, 3x squared is equal to 50. So I'm now going to times everything by 3. So I'm going to have x squared is equal to 3 times by 50. And then I'm going to divide that by 2. And then I'm going to square root it. So 3 times by 50. Oops, go to the fraction. So we're going to have 3 times by 50. And we're going to divide the whole thing by 2, which is going to be x squared is equal to 75. And then we're going to have that x is equal to the square root of 75. So root 75 is going to equal 5√3. So x is equal to plus or minus 5√3. Okay, so what we found now is that x is equal to plus or minus 5√3. So we now find out what the corresponding y values are, because we know that this occurs at the point where y is equal to 1/3 x. So we can say that the corresponding y value is going to be plus or minus 1/3 5√3. So there we go. We found our corresponding x and y points. Now let's just consider what that means on our diagram. So here's our kind of ellipse kind of shape there. So it means that the point P here must correspond to, so that's Q rather. The point P is the one we're after. It must be minus 5√3 and minus 5√3/3 is the x and the y. Q over here, just for information, is 5√3 and 5√3/3. And that's our two coordinates for P and Q. Okay, so that is that question done. Excellent. That's that part of the question done. And the reason I wanted to look at that, because I thought it was very interesting and somewhat unusual, the way that we needed to consider the denominator equaling 0 in order to get a line that was an asymptote like that, had an infinite gradient. So the final little bit of this question, so that's part B done, and the answer that we were after was minus 5 root 3 minus 5 root 3 over 3. And then the final bit, it says, which again is interesting, it says, explain briefly to find how to find the coordinates of the points that are the furthest north of the origin. Okay, now, the point that is furthest north of the origin, if we were to do that, what we would have is we would have a line like that that would be horizontal, okay? And if we go back to our gradient function from the question, what that would mean is that would mean that the gradient would be 0. And if the gradient was 0 in a fraction, the only way a fraction equals 0 is if the numerator was 0. So if we wanted this point here, let's say it's called R, for example, PQR, the point furthest north, it would occur when the gradient is 0, and the gradient would equal 0 when the numerator is equal to 0, okay? And the numerator equals 0 at the point where y equals x, y minus x equals 0. So this would be y is equal to x. That is where this would occur, okay? So what we would do is we would take y equals x and the equation of the line, x squared minus 2xy plus 3y squared equals 50. This time we'd sub y equals x in there and we would solve. This would give us a quadratic in x, which when we square root it, we'd get plus or minus two values. We would then take those two values, put them into the y equals x to get our y coordinate as well. And the positive one would be the r, and the negative value that comes out of that would give us the coordinates of the point that's furthest south, which I might call S. So that's how we would find the furthest north and the furthest south. And we found the furthest east and we found the furthest west. So I want to look at that because that was, I thought, an interesting question on implicit differentiation with quite a tricky idea in there. Okay, I hope that you found that useful, and I'll see you in the next video.